Hello, this is a walkthrough of my final project for CSCI E-90. The goal of this project was to build an event-driven log sanitization and security alerting pipeline on top of various Amazon Web Services. Accidental logging of sensitive data is a real security problem. Examples include things like passwords, API keys, credentials, and credit card information getting stored in log files. The goal here was to prevent sensitive data from being written to long-term logs while still allowing secure analytics and alerting to take place. In other words, we want to sanitize logs before they get committed to long-term storage. In addition, we also want to provide timely alerts whenever serious security events occur. At a high level, this is an event-driven pipeline built entirely with AWS managed services. It begins with a Python script that writes fake application log data into Amazon CloudWatch log groups. From there, a CloudWatch logs subscription filter streams every log event into an AWS Lambda function. The Lambda function is the core of the system. It detects personally identifiable information via regular expression pattern matching, sanitizes sensitive data, assigns a severity level to each event, and then takes multiple steps. First, it writes both the sanitized and the raw logs to Amazon S3 buckets. If a log event is classified as high or critical in severity, the Lambda function sends an alert using Amazon SNS. It also writes information back to Amazon CloudWatch for further monitoring and evaluation of the function itself. For analysis, sanitized logs are cataloged with AWS Glue, queried with Amazon Athena, and then visualized in Amazon QuickSuite. It should be noted that all information stored in the S3 buckets is encrypted with a symmetric key from Amazon Key Management Services. And in addition, Amazon Identity and Access Management is used throughout the application to ensure the concept of least privilege. In order to start the pipeline flowing, we have a Python log generator. This script simulates application behavior by writing logs directly to AWS CloudWatch. It generates a mix of normal and intentionally dirty logs. The dirty logs are designed to leak sensitive data such as plain text passwords, AWS-style access keys, and credit card numbers. This allows us to validate that the sanitization logic and alerting behavior are working as expected. After importing some libraries, we provide the script configuration parameters to point it to our AWS CloudWatch. The script currently generates 10 events at a time, with 25% of those being incidents. We have sample data pools for things like users, IP addresses, actions that the users have taken, API endpoints, and incident types that get randomly chosen in order to create our log events. One function creates a normal payload, and a second one creates a dirty one. After the payloads are created, they're then pushed to AWS CloudWatch. Finally, an event summary is printed into CloudWatch for debugging and tracking purposes. All application logs are written to AWS CloudWatch. They go into a log group entitled CSCI E-90/app logs, and from there into a log stream titled test stream. A subscription filter with a pattern of dash, meaning that it matches all logs, is configured on this log group, which also contains the ARN that Lambda uses in order to receive information from the log. This subscription filter triggers the Lambda function for every log event. This is what makes this system a fully event-driven configuration. Amazon CloudWatch delivers log events to our Lambda function. Each invocation of that function may contain multiple events, each one including a log group, log stream, individual messages, and the associated timestamps. The Lambda function decodes the payload and then iterates over each event independently. The sanitization logic is responsible for detecting and removing sensitive data from the messages before they are stored or analyzed, while still preserving enough context to make the logs operationally useful. The logic uses regular expression pattern matching in order to detect common forms of sensitive data. These include things like email addresses, IP addresses, and password fields. Regular expressions were chosen because the logs we receive from CloudWatch contain unstructured text, and regular expression pattern matching is very fast. When a sensitive value is detected, the original value is irreversibly replaced. A placeholder token is inserted, such as these listed here, like email redacted, IP redacted, etc. We also increment a counter in order to keep track of the number of redactions that occurred from a statistical perspective. This overall approach ensures that sensitive values cannot be reconstructed while keeping the type of exposure visible. This enables analytics to be able to distinguish what was redacted. The severity classification mechanism of our Lambda function translates our detection results into actionable intelligence. Instead of alerting on every redaction, the system tries to determine how serious was this exposure. The severity levels are classified as low, medium, high, and critical. A low level means that no sensitive data was detected, the information is only logged, and no alerts are sent. The medium level means that we found an email or IP address. We log that fact, but still make the information visible in our analytics, but once again, no alerts are sent. A high level means that at least one password was detected, and this triggers an SNS alert. The critical level means that an AWS access key or multiple passwords were detected. The AWS keys can enable infrastructure compromise, and multiple credentials might also indicate a systemic failure. The SNS alerts are only triggered on high and critical levels. When a high or critical level is encountered, this portion of our Lambda code creates the email that ultimately gets sent as an SNS alert. This email summarizes the events that were detected, the redactions that took place, and provides critical information to the analyst to understand what has occurred. For high and critical severity events, the Lambda function publishes an alert to an Amazon SNS topic. Each alert includes a unique alert ID, which allows us to correlate batches of events. The alert explains the overall severity and why it was classified as high or critical, and includes the triggering action, such as a failed login or API call. It also contains a summary listing all the severe events in that particular batch. No raw sensitive values are ever included in the alerts, only sanitized ones. This is an example of an email that was received with security alerts contained inside. We can see the overall severity of the event listed at the top and the reasons why the alerts were triggered. We get a breakdown of the severity level as well as a summary of the information in the alert. We provide an example of a sanitized event and then a redaction summary so we can understand exactly what was scrubbed from the logs. Finally, there's a listing of all the severe events in this particular batch. After the Lambda function has completed processing the events, log data is written to Amazon S3 buckets. Raw logs and sanitized logs are stored in separate buckets. The logs are written in the ND-JSON format, which stands for New Line Delimited JSON, making each entry its own object. This is done in order to optimize for the analytics we're performing. The data is partitioned in a year, month, day, Hive format, which improves query performance and reduces costs when using Athena. Separating the raw and sanitized data also enforces the principle of least privilege. In addition, each of the buckets is encrypted with an AWS KMS symmetric key. This is an example of a sanitized log written to our S3 bucket. AWS Glue is used to catalog the sanitized log data stored in S3. A Glue crawler scans the S3 bucket and automatically infers the schema. It also discovers partitions based on the directory structure. This metadata is stored in the Glue data catalog. Glue allows Athena and QuickSuite to query the data without manual schema management. Amazon Athena is used to query our sanitized logs directly from the S3 bucket using the standard query language, or SQL. With this approach, no database servers are required. Queries can be filtered by severity, action type, date, or a number of other parameters. This is an example of a query showing us the alert ID, severity level, and redaction stats for the last 10 log entries. Here's another example showing the total count of each one of the actions that triggered the events. An Athena view was created in order to flatten some of our nested data fields, such as the severity level. Using this view simplifies analytics and makes our QuickSuite integration more reliable. Amazon QuickSuite is used to visualize our sanitized log data. We first go in and create a data source, and then connect it as a data set to the view that we created previously in Amazon Athena. From there, we're able to perform analysis and create visuals with the data that is of interest to us. The visuals include parameters such as severity distribution, high-risk actions, and trends over time. Only sanitized data is exposed to QuickSuite. This allows the dashboards to be shared safely without exposing any sensitive information. The dashboards transform raw log data into actionable security insights. Once completed, they can be shared with interested stakeholders. Amazon CloudWatch logs also provide observability for our entire pipeline. They show incoming application logs as well as the execution of our Lambda function. We can put print statements in our Lambda code, and those are captured automatically by CloudWatch. This was done throughout the development process in order to track down errors, address permission issues, and troubleshoot schema problems. CloudWatch can also help to validate that the redaction and alerting process are working as expected. Here's an example of a CloudWatch execution log coming back from Lambda. With this level of detailed information, it's much easier to diagnose and troubleshoot problems in our code. Okay, I'm now going to run a live demo to show the pipeline in action. Let me start off by showing a couple of the current Athena queries in QuickSuite dashboards, just so we'll be able to see that the information has changed after generating and processing the log information. Here in Athena, we can see the total number of records in our S3 bucket is sitting at 1,489, and our severity counts are 249 critical, 258 high, and 982 medium. Over here in QuickSuite, when we change views, the data refreshes. We can see that the total number of critical, high, and medium severities match up with what's in Athena. Okay, so now we'll go over and we'll run our log generator script. We're going to generate 10 events, with roughly 50% of them being severe events where data is being leaked. Okay, here are the 10 events that were generated. We can see 1, 2, 3, 4, 5, actually 6 events with data leakage. If we go over to CloudWatch and look at our app logs and test stream, we can see the 10 events that were pushed into CloudWatch, and they match up with these events over here from our log generator. After the events were pushed into CloudWatch, the CloudWatch stream sent the information over to Lambda for Lambda to do the sanitization of our data. We can go and look at the CloudWatch logs for Lambda and see that it did in fact go through and sanitize our records. We can also confirm that Lambda went into the S3 buckets and wrote both our raw log, where we can see all of the data, as well as the sanitized log in a separate bucket, with the sensitive information being redacted. From here, we can go and take a look at the SNS alert that was sent through to our email, showing the 6 events that were considered high or critical. And that broke down into 4 critical and 2 high events. Here were the types of events in this exposure, the redaction summary, and then each of the individual events. Finally, we can go back into Athena, recount the number of records, and we'll see that it increased by 10 and that our severity counts went up. If we go back to our quick suite dashboards, we can see that the severity distribution now matches what was in the Athena SQL query. We have several other dashboards that we built that give us different views of the data so we can perform further analytics and investigation in order to understand what kind of alerts and data leakage we're seeing over time. This walkthrough has demonstrated the full end-to-end flow from log ingestion to alerting, as well as dashboards to help us further analyze our data. In conclusion, this project demonstrates a secure, real-time, event-driven log sanitization pipeline that was implemented using AWS CloudWatch and Lambda. We're able to take sensitive data and recognize patterns that need to be filtered out, redact that information, and remove it before writing the logs to long-term storage or performing analytics on it. Certain high-risk events generate SNS alerts that send email summaries, while low-risk events remain visible for analytical purposes. The combination of Glue, Athena, and QuickSuite enable us to query and visualize our events so we can identify trends over time. The system built is scalable, serverless, and entirely managed with AWS services. Thank you for watching.